Math board number 14 is 7 times 10 to the negative 2 a negative number? No. Okay, just because the exponent is negative does not make this a negative number. In fact, we already know how we can convert that into something with a positive exponent. And that's what we're supposed to do right here. Without changing its value, rewrite 7 times 10 to the negative 2 with a positive exponent. We would rewrite it as, so we have 7 times 10 to the negative 2. We know that on the 10, the base of 10 is the negative 2. We can take this part and change that into 7 over 10 squared. Okay? Which would be 7 over 10 squared, or 7 over 100. It says simplify your answer in number 2. I would be fine with saying it's either 7 over 100 or 0.07. Okay, 7 divided by 100 would be 0.07. Okay, rewrite, oops, I guess I went ahead. Okay, simplify your answer. I guess this is 7 over 10 squared, and this divided by 10 squared, and this is 7 divided by 100, and write this as a decimal. All right, fine. Do that down here. If 7 times 10 to the negative 2 is measured in meters, how many centimeters is that? So 0.07, meters is equal to how many centimeters? That's what the question is. So I think I'll come over here and I'll say, here's meters, and then these are decimeters. Oh, that should be an M. This should be centimeters, and then millimeters. I want to know, each one of these is 10 to the first power. So to move from here to here is 10 to the first. To move from here to here is 10 to the first. To move from here to here is 10 to the first. However, if I move from here to here, it's 10 to the first, which is 10, times 10 to the first. 10 to the first times 10 to the first. Right? They have the same base. Add the exponents is really 10 squared, and 10 squared is 10 times 10, or 100. Okay? So, what I would need to do, if in 1 meter is 100 centimeters, I take this number and multiply it by 100. So 0.07 meters times 100, 0.07 meters times 100 is the same as saying 7 centimeters. Which of the following could have a measure of 7 times 10 to the negative 2? In other words, 7 centimeters. Which one of these could be 7 centimeters? Not a door. Okay. Approximate the square root of 11 to the nearest tenth. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. If I approximate this to the nearest tenth, it's somewhere between the numbers 3 and 4. 11 is definitely closer to 9 than it is to 16. So I think I'm not going to guess 3 because I already know that's 9, but I guess I'll check 3.1, 3.2, 3.3. I'll see if one of those. Again, if you were going to do this and you couldn't use a calculator, you would say 3.1 times 3.1 and you would figure it out by hand. But I'm trying to be faster on the video, so I'll do it by a calculator. So 3.1 squared is 9.61. 3.2 squared is 10.24. 3.3 squared is 10.89. Oh, that could be a winner. Let's see what 3.4 is. 3.4 squared is 11.56. Okay, so this is 56 100ths away from 11. right, over. And this is 11/100ths away. So this one is closer. So 3.3 is where I would approximate it. You were distracted and won only 8 out of 22 games that you played on your phone. After that, you decided you wanted to raise your winning score to 80%. How many games would you have to win in a row in order to reach that record? Create an equation and solve for the variable. Okay, so let x equal the number of games. The number, we've already played 22. We're figuring out how many more games we need to play where we get every single one of those games, we win them in order to get an 80%. So here is our current percentage, 8 divided by 22. Okay, obviously we have it in a fraction form, but we could figure out the decimal to figure out where we are now. But then we need to add the number of games. So 8 plus how many more winning, right? How many more we need to win. So this number needs to get larger by what we've already won and how many more we need to win. We've already played 22. This isn't going to stay 22 because we're still playing games. We're just going to make sure we win each one. Okay, so this is going to be 8 plus x over 22 plus x. X is the number of games that I need to win. And I'm assuming that I'm going to win every single game from here on out. And that needs to be equal to 80%. Well, we don't work with percentages like that. We need to make them into decimals. So 8 plus x divided by 22 plus x equals 0.8. Okay, and then now I am going to, you can kind of think of this as a proportion. You could put that over 1 and multiply that out. So I would have 8 plus x times 1, so that doesn't change anything, equals 0.8 times 22 plus x. Okay, so 8 plus x equals 0.8 times 22, 17.6 plus 0.8x. You can ignore this. I need to get all of the x's onto the same side, so I'll subtract 0.8x, 0.8x. That's going to give me 8 plus 0.2x equals 17.6. Subtract the 8 from both sides. 0.2x equals 9.6. And divide both sides by 0.2 or 2/10. And 9.6 divided by 0.2 will be 48. Games. And then you can check that that's right by substituting the 48 in here. So 48 plus 8 is going to be 56 divided by 48 plus 22, that's going to be 50, 60, 70. And 56 divided by 70, you can simplify that. Let's see what number goes into both of those. 7 goes into both of those. 56 divided by 7 is 8. And 70 divided by 7 is 10. And 8/10 is the same as 80%. Show algebraically why you cannot get a winning score of 100% in problem number 8. Alright, well, 100%, that's going to be, instead of equal to 80% was 0.8, 100% is going to be equal to 1. So I need to set up the same equation, 8 plus x divided by 22 plus x, and that is supposed to be equal to 1. And again, we could set that up as a proportion. We'll multiply like this. 8 plus x times 1 is just going to be 8 plus x, equal to 22 plus x times 1 is just 22 plus x. I like to eliminate my variable first. When I do that, this gets eliminated, turns into a 0, this turns into a 0, and I'm left with 8 equals 22, which is false. No solution. Therefore, you just algebraically show that you cannot get 100%. Number 10, what's the easiest way to show that the table of values does not satisfy the equation y equals 3x plus 4? Okay, well, if I substitute any of these numbers for the input, I should be able to get the output. So let's say I used x equals 2. So 3 times 2 is 6, and 6 plus 4 is 10. Well, this is not 10. Okay, so this equation does not satisfy that table. And so I guess answering question, substitute an x value or an input and calculate y, or the output, and see if it's the same. In the table above, the x values are 1 unit apart. Okay, so yeah, they are. These are 1 unit apart. In this case, what is the easiest way to find the slope of this linear relationship? Well, we already know that slope is the change in y over the change in x. They're telling us that the change in x is going to be 1, and we can look at that and tell that it is 1. So the easiest way to find the slope would just be to subtract any of these numbers. Okay, so this would be 1 minus 0, so I would be 2 minus 0. So the slope here would be 2. Does the relationship in the table above represent a function? We haven't really talked about functions, but in a function you can only have one output for every one input. Okay, so that means you can only use the input values one time. Well, if you look at this, here are our input values. 0 is used one time. It's not a repeat anywhere. That's okay. 1 has an output of 1. Oh, wait. 1 has an output of negative 1. For every output, there is only one input. Here is an output of 1 and an output of negative 1. However, for both of these output, the input was the same, so that doesn't follow the rule. For every output, there is only one input. This input of 1 has 2 different outputs. This input of 2 has 2 different outputs. Therefore, it does not satisfy the definition of a function. No. There are 2 outputs for both 1 and 2. Without plotting the points from the table above, how can you show that the graph is not linear? Well, if they are linear, then the slope is consistent between every 2 points. Okay, so let's figure out the slope right here. This is a plus 1, right? Negative 2 to negative 1, you add 1. To go from 4 to 1, you subtract 3. So the slope right here is a negative 3 over 1. If this is linear, when I figure out the slope here between these 2 points, I should get the same thing. Okay, negative 1 to 0, that is adding 1. Okay, so that part's the same. 1 to 0, that was subtracting 1. So that is enough right there to say that this is not linear, because the rate of change between the points is not consistent. Without plotting, can you show the graph is not linear? Yes. Calculate slope.